Let me draw that figure first. There is a mass m1 here. There is a thread and a mass m2. Now, in the system shown in this figure, the mass of bodies are known to be m1 and m2. The coefficient of friction between body and m1 is equal to k. Pulley of mass m is assumed to be uniform disk. There is a disk. The thread does not slip over the pulley, no slipping. At moment t equal to 0, the body m2 start descending, assuming the mass of thread and friction in Excel to be negligible. Find work performed by the frictional force acting on body m1 over the first t second after the beginning of motion. Work performed by frictional force, that is asked by us. Now, मैं 3 फ्री बॉडी डायग्राम पहले बनाता हूं. एक तो फ्री बॉडी डायग्राम इस मास m1 का बनना चाहिए. दूसरा फ्री बॉडी डायग्राम इस पुली का बनना चाहिए. और तीसरा फ्री बॉडी डायग्राम इस मास m2 का बनना चाहिए. मास m1 के लिए मैं कहूंगा ग्रेविटेशनल फोर्स m1g, normal reaction N is equal to m1g, and here we'll observe some tension T1, and there would be a opposing frictional force, and that opposing frictional force Fr would be mu n, or that frictional force would be mu into m1g. This is the free body diagram for mass m1. Here for the pulley we will observe T1, and here some tension T2, and here some tension T, and this is, let us say, accelerated, and this is angular accelerated alpha, which is equal to A by R, and here m2g, T2, and acceleration A. I would write equations now for this mass m2g minus T2 is equal to m2a. For this pulley, T2r minus T1r is equal to I alpha. I is half mr square and alpha is A by R. And for this I will write T1 minus mu m1g is equal to m1 into A. Now observe that this R would get cancelled throughout, and we can add the 3 equations, and after adding the 3 equations, T1 would get cancelled, T2 would get cancelled, and we'll get m2g minus mu m1g is equal to m2 plus m by 2 plus m1 into A. And this would give us the acceleration of the system, m2 minus mu m1 into g upon m1 plus m2 plus m by 2. This is the acceleration of the system. Now, that asked us the work done by friction during the first t seconds. तो first t seconds में हम कहेंगे displacement क्या है? Displacement s is half at square, or half for acceleration. I'll write m2 minus mu m1 into g by m1 plus m2 plus m by 2 into t square. Frictional force is mu m1g. Now, in order to write the final answer, work done by frictional force is Fr into displacement. Work done by frictional force is mu m1 g by 2 into m2 minus mu m1 into gt square by m1 plus m2 plus m by 2. Or finally, I will write work done as mu m1 g square t square into m2 minus mu m1 upon twice m1 plus twice m2 plus m. This is work done by friction. Work done by friction over first t seconds. तो ध्यान से देख लीजिए, एक्सीलरेशन निकाल लिया है और यह एक्सीलरेशन जो है कांस्टेंट है, कांस्टेंट एक्सीलरेशन आ रहा है, कांस्टेंट एक्सीलरेशन से डिस्प्लेसमेंट निकाल लिया फर्स्ट t सेकंड्स के लिए. फ्रिक्शनल फोर्स हमें दिख ही रहा है, वर्क डन बाय फ्रिक्शन इज फ्रिक्शनल फोर्स इनटू डिस्प्लेसमेंट. फ्रिक्शनल फोर्स इनटू डिस्प्लेसमेंट कर दिया एंड विल गेट द आंसर. प्लीज नोट डाउन. I will solve problem number 1.236 for you. Now, a force F1 is equal to AJ is applied to a point whose radius vector R1 is AI. This is the radius vector of F1. While a force F2, which is equal to BI, is applied to a point whose radius vector R2 is BJ. Both radius vector are determined relative to origin of coordinate O. I and J are unit vector, X and Y are axis. Along the axis X and Y, A, B, capital AB are constant, arm length L of the resultant force. Now, once again, let's try to understand how these forces are applied. Force F1 is applied like this, it's at R1 I cap, this is A comma 0 and force F1 is AJ. This is force F1 is equal to AJ and it's applied at this point P1, which is at A comma 0, and this force F2, which is BI and it's applied at this point P2, which is having coordinate 0 comma B. In this case we have got two different forces applied at two different points. Now we need to determine the arm length. आर्म लेंथ डिटरमाइन करने के लिए पहले हमें मोमेंट ऑफ फोर्स निकालना पड़ेगा, मतलब टॉर्क निकालना पड़ेगा. दो अलग अलग फोर्सेस की वजह से जो टॉर्क निकाला जाएगा, विल से दोनों फोर्सेस के लिए हम टॉर्क अलग अलग निकालेंगे और टॉर्क को ऐड करेंगे. दिस N1 is R1 cross F1, N2 is R2 cross F2. When two forces are acting at two different points, then the torque would be calculated separately, determined separately, and then the torque would be added. This normal reaction or this moment of force N or torque would be R1 cross F1. R1 is AI cap cross A J cap. This is R1 cross F1. Then plus R2 cross F2. R2 is BJ cap cross F2 is BI cap. So this would give me N is A into A, I cross J is plus K, plus B into B, J cross I is minus K, or this is AA minus BB into K cap, and mod of this moment is AA minus BB. There is a mod. Now that asks for the arm length. How do you define arm length? Arm length is defined as mod of force into arm length L. Arm length L is equal to the mod of torque. Now, what is the mod of force? The forces are perpendicular. So, mod of force is under root of F1 square, F2 square into L is mod of. So, F1 square is under root of A square plus B square into arm length L is AA minus BB. So, arm length L would be given by AA minus BB upon under root of A square plus B square, and this is the answer. In previous situation, we have got a single force acting at a point. When a single force acting at a point, we can calculate torque. But when in this situation, we have got two forces acting at two different points. When we have got two different forces acting at two different points, we determine torque separately by the two forces, and then we add the torque to get the overall torque or to get overall moment of force. And this is how we determine moment of force. Here K cap is unit vector along Z axis. There is the magnitude of moment of force, and this is the definition of arm length, and we determine the arm length. Please note it.